Hey everyone, this is Mr. Kerr. This video is going to be looking at the last balancing quiz that we did. I'm going to be taking it up. So I just wanted to review why we're balancing. So the whole idea is to have the same number of atoms in the reactants and the products. You can't just suddenly lose or create atoms. And the way you do that is you can't just change the number of alumins. I can't put down Al2 and then scratch this out and put O3. It doesn't work like that. All you can do is you can change the multiples of atoms or molecules. So I can put a coefficient in front of each of these. So let's look at an example and get a better idea of what's going on here. So first thing we do is we look at the overall number of atoms on both sides. Do a little tally chart. Might be in our heads, but we want to have a tally chart. So you got 1 aluminum, 2 oxygen. Here you've got 2 aluminums and 3 oxygens. Now, whenever you have an odd number on one side compared to the other, what you want to do is you want to even it up. So what you do is you double up the odd. So I'm going to put a 2 in front here, and that's going to give me 2 times 3 or 6 oxygen atoms. But it's also going to change the aluminum. That's okay. I'm going to have 4 as a result. Now on this side, to balance things, let's put a 4 in front here to give me 4 aluminum atoms. Now the oxygen, remember, I need to have a 6. So how do I get that 6 here? Put a 3 in front. 3 times 2 is 6. And it looks like we're balanced. Yeah. And we just check to see if we can further reduce. Nope. That's it. We're balanced over here. Okay, now what I've done here is I've just put in the tally chart again for each of these. Again, you don't have to have it written down. You can do it in your head if you want to. Just go through the other examples. So now we've got potassium chloride being broken down to potassium chloride and oxygen. How does that work? Well, we've got 1 potassium, 1 chlorine, beautiful. Here, look at this, an odd and even number. So we make this an even number by putting a 2 in front. And it's going to change the number of potassiums and chlorines. That's okay, but we're now going to have 6 oxygens. So what can we do here? Well, let's look at this. Oh, look, the potassium chlorine, if I put a 2 in front, they're going to be nicely balanced. And to make this 6 oxygens, I put a 3 in front, 6 oxygens. We're good. And let's just check these. We can reduce. Nope, that's it. We're done with this one as well. Okay, let's continue over here. So the next one, we've got 1, 1. Oh, look, it's the hydrogens that are off here. So we need to have an even number. So to do that, let's double up the number of hydrogens here. So this is going to be 2 nitrogens, 6 hydrogens. We still have the 2 oxygens. That hasn't changed. I need to fix things. So let's look at this. I need to have the hydrogens. I need to have 6 hydrogens. So put 3 in front here. Me a 6. That does change the number of oxygens though. So I've got 3, 4 oxygens as a result. Oh, that's not, but then we also have to change the number of nitrogens. So here you need to have 2 nitrogens, but that also changes the number of oxygens. So now I've got 1, 2, 3, 4, 5 oxygens. Oh, this is going to be terrible. But here's a little trick for you guys. What you can do is the following. You can look at this and say, okay, I've got an uneven number. So to even things up, what if I doubled one of these up? Well, you can do that, but there's an easier way. What if I say I need 5 oxygens on this side, but if I put a 5 in front here, that gives me 10. What if I did this? 5 halves. Remember, half of an oxygen is, a molecule is a single oxygen atom. So half oxygen molecule is 1 oxygen. So I can just do this. So 5 halves is really 5 oxygen. So it's going to be balanced, but I can't leave it as a fraction. So what you have to do is we have to get rid of it. So we multiply everything by 2. So this becomes 4. This stays as 5 now instead of 5 halves. This becomes 4, and this becomes 6. Let's see what happened here. All right. So you're going to have 4 nitrogens. We're going to have 4 times 3 is 12 hydrogens. And we've got now 10 oxygen molecules, or atoms. On this side, we're going to have 4 nitrogen. How about the oxygen? You have 4 plus 6 gives us 10. And finally, how many of these hydrogens? Looks like we have 12. We're all balanced. And let's just very quickly check to see if we have to do anything here. Nope, we don't have to reduce any more. So that was a little bit tricky, but remember, just keep this in mind. If you want to have a single oxygen, it's half of an oxygen molecule. You see this fraction show up again in a little bit. Okay, let's look at this one here. We got barium bromide, aluminum sulfate. Let's see what happens. All right, so we've got an even number of bariums. Oh, bromines are off. Okay, let's look at what we can do here. So let's make this one even here. Okay, so we're going to change the number of aluminums. And we're going to have now 6 bromines. Bit of an issue, but we can deal with that. Let's go into this side. Well, what if I want to have 6 bromines? I have to put a 3 in front here. So I'm now going to have 6 bromines, but remember, I also change the number of bariums. So if I change the bariums, I have to change them on this side. But wait a second, I have 3 bariums. How about this? I've got sulfates. Well, sulfate appears on both sides. So try to keep polyatomics together as much as you can. You can see here I've got sulfate, 3 of them, 3 sulfates. Oh, look at this. This is great. So I got 3 sulfates all together. And what else do we have here? That's it. We're done. And then we just double check. Can I reduce? Nope. We're good to go there too. All right, let's look at this one. You have a combustion reaction. So in this combustion reaction, you have to keep in mind, whenever you're doing these reactions, you always do them in this order. CHO, CHO. Do the carbons, hydrogens, oxygens. You do that, it's easy to do. All right, let's check what we have here. We got 2 carbons, so I got to even out the carbons. So I'm going to put a 2 in front. Beautiful. That does affect the number of oxygens. That's okay. I have 4, 5 oxygens. Let's look at the hydrogens. I've got 6, so I need to have 6 here. Put a 3 in front. So I've got 6, but I did affect the number of oxygens. So I have 3, 4, 5, 6, 7 oxygens. Oh, now, I need to have 7 oxygens here. So remember, 7 halves of an oxygen molecule is equal to 7 oxygen atoms. We did that before. And now what we can do is simply multiply everything by 2. Put a 2 in front. Multiply this by 2. Put a 4 here, change this to a 6. Remember, all we did is just double everything. Let's see what happened here. So now I've got 4 carbons, 12 hydrogens. What do I have here? It looks like 14 oxygens. Here I've got 4 carbons. They're balanced. That's great. How about the oxygens? I got 4, I got 8, but then I got another 6 here, so it's going to be 14 oxygens. And the hydrogens, they're 12. That's it. We're done. We're balanced. So basically, the way to do these again, combustion reactions, always do these in this sequence. So carbon, hydrogen, oxygen, and sometimes you have to do the fraction with the oxygen. Okay, let's move on to the last one now. Okay, let's look at the last example here. So you got iron 3 oxide, carbon monoxide giving us carbon dioxide and iron. This is a common reaction in steel mills. So it's a really practical example of chemical reactions. So let's look at the balancing here. So it's like the irons are up. I'm going to leave the iron atom for the end and try to focus on the more complex compounds here. Carbons are okay. Well, oxygens are off. So let's look at the oxygens. Let's put a double here. So 2 oxygens. So that gives me 2 and then 4 oxygens. Let's put a 2 here just for good sake. So 2. So it looks like we're balanced. Oh, no, we're not. The carbons are not balanced. So now I have to go back. I have to balance out the carbon over here. So I'm going to have 2 carbons, but I've changed the number of oxygens. Now I've got 3, 4, 5 oxygens. So I need more oxygens on this side. Let's just make this a 3. We need 1 more. So I'll add this to 3. So we're going to have 3 carbons. Looks like 6 oxygens. We have our 2 irons. Oh, we need more. I need to have 6 oxygens here. So what if I put a 3 in front here? So now I'm going to have 3 and 3 gives me 6 oxygens. I'm going to have 3 carbons and my iron is balanced. And so the whole reaction's balanced, and that's it. So some of these, like this last one, you might be stuck in a rut. If you are, just try a different approach. Eventually you'll get it. Okay, that's it.